either conceptually or by number. That's the average velocity. Looking for the change. You did say, that was the number that you just said, Logan, right? That number?
Mm-hmm.
Okay, yeah, that's average. How do you find change?
Final minus initial.
So, final minus the initial over time. What's the final velocity?
Is it 19.6?
We're talking about, it's at the pavement already.
2.
What's the initial velocity? That's when that comes in, 19.796. And how much time? That's how long it took to fall. We're just dealing with it's touching the pavement and it's stopped. Is it a negative?
I know it's negative 0.002.
No, time is not gonna be negative, I hope.
0.002.
Yeah, it's this one.
Oh, it looks like a negative.
So 0.00202. So the acceleration is a negative number, which I would hope, because velocity is positive and it slows down, so acceleration better be the opposite sign. And so what does this end up being? I got the negative part. So it's somewhere around 100, pardon?
Oh, somewhere.
Sorry, I interrupted you.
Well, I'm at negative 9,800, but that isn't.
I'm off by some decimal points. 9,800? I'll give another look again.
Meters per second.
All right. I think in the original problem, I then asked what was the actual normal force, what was the average normal force acting on it? Not in the master set, because the extension would involve stuff from chapter 4. But these are old test questions, the original test question that Joe said.
So for the one that talks about an average velocity at the stop, you said that was the same as average velocity as it's falling?
Yes, because it goes from 0 to something, and then that something to 0 again. That's why the average is the same. But clearly, falling before it touches the pavement, 9.8 meters per second squared, and when it hits, negative 9,800 meters per second squared.
So
Elizabeth?
the 0.00202, what was that the time for?
The time to stop, that was the time, it was 2.02 seconds to get to the pavement, and then 0.00202 seconds to actually stop once it touches the pavement. The beauty of this problem, it's two problems in one. You've got the falling and then the stopping. Now, for those who haven't touched the master set yet, I believe the master set problem takes place on Mars, not on Earth. So the acceleration while it's falling will be different. Better said, the acceleration while it's free falling will be different. Were your questions answered? Is that what you're looking for? Other questions on this? Other questions?
For the
test, are we gonna have to memorize the gravity of all the planets?
No. At the top of the first page should be the acceleration due to gravity for any celestial body you might need. If I forget to put it on there and you need it, just ask. If you wanna mess with other people's heads, ask for the acceleration due to gravity for something that you know you don't need at all, and I'll write it on the board.
Is there anywhere we can find out the equation?
So if you look at the old tests, at the top of the old test, it's under supplemental material, I think, old tests, something like that. If you look there at the top, those are the formulas. But in essence, I take, although chapter 3 doesn't seem to have any, in the summary section, sometimes there are formulas here, so I would give you anything in the summary section, and any of the formulas here under plug and chug. And then the variations of formulas that I did that Hewitt doesn't. All right. Let me just do one more extension of this problem. What is the average velocity for the entire trip? Acceleration is not constant. How would you find the average velocity if acceleration is not constant? Yeah, there's a formula over there. In here. Oh, don't make me sit down again. It's tough enough to get back up.
Displacement equals half acceleration times 3. Is that a formula?
We're trying to find average velocity, so that would be to find, no, that wouldn't get you average acceleration. Yeah, no, that would, that assumes acceleration is constant.
Would it be the initial plus the final divided by 2?
That assumes acceleration is constant. We're looking for something that's true even if acceleration is not constant,
Is it that one?
which is, which one?
Displacement equals average velocity times time?
It is indeed that one. So the displacement for this trip, it goes 20 meters, then it goes an extra 2 centimeters, so my average velocity is displacement, it's supposed to be an x, divided by time. So the average velocity is 20.02 meters. Divided by the amount of time, well, it took 2.02 seconds to get to the pavement, and then 0.00202 seconds to actually stop. So this would be 2.02202 seconds. Now with rounding, it's gonna come out very close to 9.898. But to find average velocity if acceleration changes, you have to go this route.
Where do you get 20.02 from?
The total travel, it started 20 meters, it fell 20 meters to the pavement, and then an additional 0.02 meters into the pavement. And then the time, we have the time to the pavement, and then the time into the pavement.
So it's finding average velocity when acceleration isn't constant.
Yes. And what will be the units when we find average velocity that way? What will the units be? Yes. We just said that. Okay. Sorry, when I asked that, it might have come across harsh. It was not. Who said that? All right. Other questions about chapter 3 before we talk about when master set 3 is due and start talking about chapter 4?
Would you divide that, or do you want the answer like that?
The units, for a final answer, the units do need to be separate and only one fraction per numeric answer. I consider the decimal as like a fraction, and so this is 3. That part right there is 3 decimal places, or sorry, 3 fractions, so it does need to be either multiplied by 100,000, put it into improper fraction form, or actually do the division on your calculator. But this would not be a sufficient final answer. And then units, so then you'd have a number and then units as a separate.
So it'd be 9.90.
9.90? Okay. It was gonna be very similar to that because it doesn't spend much time on the pavement or go very far. Sasha, is that one a look of deep thought, or you're about to ask a question? If you suddenly just shout Eureka, I assume you've figured out some major truth of the universe. Okay, so today, today's the 29th. Master set 3, let's just say a week from today. I think on Blackboard, it's gonna say Master set 3 is due Thursday. Just, are you fine if I just don't change that and you know it's due a week from today, or is it mess with people's heads, it messes with your head? All right, I will try to remember to change it. If I forget, feel free to send me an email saying, hey, old man, what's wrong with your memory? We're gonna change this.
It's after that, so like 3:30.
Yes, yeah, I'm keeping that as is. There were 2, there was that's right. The online one was due Thursday, and the in-class one is due the Tuesday, following Tuesday. A look of question on that.
The online?
All right.
is due Thursday?
I think that's,
It says on Blackboard it's due
Today.
I think it's Thursday.
Yeah, and what is it?
it was Thursday in my head. Did I put down, it's also possible I just put down the wrong date because I had a moment.
It says doctors due September 7th,
Yeah.
and then your motion is due September 5th. On left.
So I had them both due next week. Okay, we'll go with that.
So when is master set 3 or 4 and 5 due?
We'll let you know when we get done with 3 and 4, or 4 and 5. One of those numbers.
I don't think it has September 5th.
Thursday.
Yeah, probably we'll get that.
2 is due this Thursday, or no, 3 is due. I don't know. Ignore me.
Now, it might come across like
Yeah, 2 is due last week.
I've reached some sort of, old age type memory thing, but I've been doing this for the past almost 60 years. So I'm almost 60. So my forgetting stuff, it's not a sign of anything other than me.
So both the labs are due next week.
That is, if whatever's, for the labs, whatever I have posted on Blackboard, that is what we're doing. I've just been told that one is September 5th, the other one is September 7th,
So master says still do Thursday, or Tuesday. But we-
which would be the 5th.
Okay.
And I will try to remember, good luck on that one, try to remember to actually change it in Blackboard, just so it doesn't mess with people's heads. You look like you're about to ask a question, Briley.
And the 2 labs are due next Thursday. Or,
The one lab is due next Tuesday, the other one is due Thursday of next week.
Is due it, and breakthrough.
All right, how about this? While you are doing the lab, I will write the stuff down and I will put it up on a piece of paper somewhere, probably in the lab room, because that's where we're gonna be. And that'll be what we'll call the official calendar. It'd be really cool if they did not want me to actually have the grade center completely set up in Blackboard before we begin, because that really messes up the way I usually do things, of figuring out when due dates are as it's appropriate, as opposed to guessing before we. Oh, I guess we are gonna do 4, because, that's right, this class isn't an hour and 15 minutes long, or, 3 hours. And Elizabeth apparently is ready to go. All right, let's head out down to the lab to finish up the linear motion. If you're still not finished with the linear motion, then after today, then we'll have to go to some plan B for you. I'm not gonna give additional lab time for that activity.